Okay, we're going to start talking about measurement and questionnaire, specifically in this lecture, levels of measurement. So putting it simplistically, what we're trying to do is really convert the answers into computer language. So if, for example, and you're probably all quite familiar with the Likert scale, where a statement is made and you probably strongly disagree, or neutral, or strongly agree, or agree. Those are all allocated numbers, and that's a way of translating it into computer language, if I can put that in inverted commas. Yeah, it sounds quite, as I said, simplistic, but it's actually quite complicated because, or quite important, should I say, because the type of data that you collect has a direct impact on the type of statistical analyses that you can do. So that's why it's important that when you're collecting data, and when you're measuring aspects and perceptions, that you really understand the nature and the implications of the data that you can collect. So we're going to start by going through the types of responses or measurement scales, and we're going to talk about 4 types of scales. There are basically 4 types. They're all related and really build on each other. So I'll take you through them. The first one is nominal scales. So it's really used to categorize objects or name them. So you're either in a category or not. So you're either male or female. There's no order implied along any dimension. It doesn't necessarily mean that, say, if you're looking at a dog or a cat, that a dog is better than a cat, or vice versa. So whether you allocate something a 1 or a 2 is meaningless. It doesn't mean anything. So for example, yes, no, can be choose one, choose all that apply. There's no order implied along those. So some examples: immediately after paddling on the Nahoon River, I generally feel exhausted, invigorated, thirsty, sweaty, overheated, or nauseated. Indicate your gender, male or female. Have you ever resided in Southernwood? Yes or no. So those could be allocated number 1 or 0 or 2 or 3. It doesn't really matter. So ordinal scales, really there is an order implied here, and is really used to rank objects according to the amount that they possess. So it reflects the type of levels. It ranges from high amounts to low amounts, or low to high. Ranking has no absolute zero, so there's no absolute zero. But intervals from one rank to the next are not the same. So if we can think of an example of your performance in class, someone will come first, second, third, or fourth, but doesn't necessarily mean that the distance between first and second is the same as between second and third. So for example, the first person could get 90%, number 2 could get 89, and number 3 could get 77. But nevertheless, it does give an indication of the rank of the different individuals in that case. Yeah, Likert scales are ordinal, but sometimes they're treated as interval scales. It's quite an interesting debate, because many of the statistical tests that are used assume that Likert scales are interval. So it's one of those places where there's some academic debate about issues. Obviously that's beyond the scope of this course. Okay, some examples of ordinal scales, as I've mentioned already: horse race, class achievement, highest degree earned. PhD is clearly higher than a master's, which is higher than a honors, but is the difference between them equal? Order of preference, higher number. An important thing that one has to consider is watch for reverse coding, because often when you use ordinal scales, and you'll find them in a lot of the questionnaires that you fill in, that it doesn't, if everything is going one way, it changes and goes the other way. So it's a reverse scale, which means that more is less. And I'll explain that to you a little bit later in more detail. So examples of ordinal scales: rank order your campus living preference, reason for attending this lecture, well, probably not applicable anymore. Surveys of my life, my mother sent me to get handouts, my thirst for knowledge. Those are all examples of ordinal scale. Looking at interval scale, it's similar to ordinal, except that the difference between intervals is equal. So the difference between 1 and 2 is the same as the difference between 4 and 5. And the focus is still on the amount of the characteristics that an object possesses. Okay, so here is just setting out exactly what we mean by a Likert scale. It's from 5 to 1, and it's important that 5 is strongly agree, because that implies more. And in terms of computer language, in inverted commas, or SPSS, it's important that 5 is coded, or strongly agree is coded 5. Some examples. Yeah, where you can see there is a difference between a Likert scale type example and non-Likert type scale example. Ratio scales, generally used in scientific studies, and there is an absolute zero, so something can be hypothetically zero. I have all the characteristics of the nominal, ordinal and interval scales, and can be converted into ordinal scales. So if you think a typical example would be if you are asking someone their age. In my case, you'd put 29. In your case, you probably put 19. So we could put we could group people. So we could group people from say 50 or 18 to 20. That would be group 1. Group 2 could be 21 to 25, and in my case it would be 26 to 30. And I'll just give some sort of illustrations there: income, age, number of years of education, meeting with academic advisor, etc. Some examples of ratio scales, I've set them out there. I'm not going to read through them all, you can read them quietly yourself. Yeah, so that's really the type of measurement scales that we can use. How we actually go about collecting that data, we're going to deal with in the next section. But before we get there, I want you to have a look at this questionnaire, and I want you to consider the type of data that they are collecting there. Is it nominal, ordinal, ratio, interval? What type is it? And we'll try and discuss it in class when we get there. So just spend a bit of time working through it. It's quite interesting, and it'll be really good value for you. Okay, so that's the end of that lecture. I know that we went through it quite quickly, but nevertheless, I think all the examples are quite apparent, and a lot of that stuff is in your textbook. So if you're not sure about something, you can read through that, but I think we've highlighted the most important elements.